I have some problem with it. Okay. Hello, everyone. My name is Alfredo Garcia de Vinosa. I am a young ambassador of the European Marine Board, and today I am going to be the moderator of this session. This webinar is special because it's part of a satellite event hosted by the Ocean Decade Conference that will be celebrated in Barcelona in April 9, concretely. First of all, I want to remember our please, Paula, the next, our housekeeping rules. Please make sure your name is clearly entered. Keep your microphone muted unless you are speaking. Raise your hand if you would like to speak, and you can also use the chat function to make comments and questions. And please be respectful and use appropriate language. And also, I want to remember what the ECOP network is. Please, Paula, the next. The ECOP network is a network for early career ocean professionals at EMB member organization. It was established by European Marine Board Young Ambassadors and Secretariat. It's a good opportunity to network and meet peers across Europe and to gain a voice at the European Marine Board level. So next, please, Paula. Then our speaking today are looking for early career ocean professional perspective about digital twins of the ocean. In this way, we are going to encourage you to participate in a survey that they have prepared. We are going to share a link to access to this survey during and after the event. So I'm going to introduce our speakers and their presentation. We have divided this session in two presentations. The first presentation will be on EDITO, building the core public infrastructure of the European Digital Twin Ocean, introduction to the EDITO intra-platform and science policy application of EDITO. This part of the talk could be given by Audrey Hasson. She is going to tell us more like an introduction of this EDITO, and also give she is going to give us some concrete example of application. Also participate in this first presentation, Chloe Delpont-Ramat. She is going to speak us more about the technical part of the EDITO. I'm going to introduce there and then. Chloe is currently a full stack developer at Mercator Ocean International, working on EDITO Infra and European Union funded project building the core public infrastructure for the European digital twin of the Ocean Initiative. She has a background in computer science and arts and has been working in the marine science sector for nearly 1 year. Audrey is the European Union coordinator for the Geo Blue Planet initiative, hosted by Mercator Ocean International as part of the EU for Oceans Observer, European Commission Horizon project. She's a trained physical oceanographer specialized in remote sensing. She holds a PhD from the University of Toulouse and has worked as a postdoctoral researcher for the American, French, and European space agencies, as NASA, for example. The second presentation, please, Paula, next. The second presentation will be on Iliad, digital twins of the ocean, developing virtual representation of the sea, interacting air observing, modeling, and digital infrastructure to provide prediction of future development at sea. This presentation is going to be given by Babis Ipektsidis. Sorry, Babis, for the pronunciation of your surname. He's from the net company Intersoft, based in Belgium. Babis is a member of the coordination team of the European Commission funding Iliad project. He has master degree in European Studies on Society, Science and Technology, and he has a master in international business study from Maastricht University in the Netherlands. He has been working the last 15 years in European projects. So thanks of all of our three speakers of today. I think that the first of them is Audrey. So Audrey, the floor is yours.
Thank you, Alfredo. Let me share my my screen. Boop, boop, boop. Here we go. Can you see it all right, Alfredo?
Perfect.
Perfect, great. So we wanted to first give you an introduction of what the digital twins of the ocean could be used for, because as Alfredo mentioned before, this virtual event is part of another event, official side event from the UN Decade, the UN Ocean Decade event in Barcelona that will happen in just 1 month. And the event is called DTO for ECOPs. So DTO, I'm just going to spell it out so we're all on the same page. So DTO is the digital twin of the ocean, and ECOPs is the early career ocean professional. So what we want to try to do here is to bring the voice of the ECOPs, of the early career, to the digital twin of the ocean. So when we are developing the digital twin, we already take into account the needs and the view of the future users who are the early career ocean professional. And this is the entire idea, rationale behind this virtual and then the in-person event. So this first presentation will give you an overview on one particular example on how we see, or maybe I see, the use of the digital twin, but then it will be up to you to tell us how you want to use it. And then Chloe will give you a more technical presentation on what is actually the digital twin of the ocean, because you will see, I'm not going to go into much details, but first let's look into the digital twin of the ocean for informed decision making. Decision as being a decision made by a policymaker or by someone who need to do mitigation, such as like cleaning a beach from a certain algae, from a marine litter, whatever. And this is the kind of work we do as part of GeoBlue Planet. And GeoBlue Planet is an initiative, that is the European office is implemented by Mercator Océan International here in Toulouse. So at GeoBlue Planet, what do? We bridge the gap between data, be it ocean, coastal, modeling, remote sensing, in situ, you name it, and societal needs. So this includes bridging the gap between the twin of the ocean and what is actually needed by the people on the ground to deliver actionable information. Because as you know, if you just throw data at people, that will not help for decision making. So you need to transform all this data to deliver information that is usable, so actionable information. So one application I wanted to share with you today was marine litter, because marine debris, marine litter pollution is a growing transboundary, multi-dimensional problem. We've seen marine litter, plastic being on the seafloor, on oil beach, on the Antarctic, in the Arctic Ocean, and there is a lot of environmental, cultural, economic, human health risk. There are costs, and all of this is all of this is highlighted by the United Nations, working really strongly on this. We know that there is approximately between 75 and 199 million tons of plastic that are already in the ocean, and the annual emissions are projected to double between 2016 and 2030. So it is a growing problem, and it is one that needs to be addressed. So through the different UNEA, so these are the General Assembly of the United Nations Environment Programme. There have been many resolutions from the first UNEA up to the last that was actually about 10 days ago in Nairobi. And the most, I would say, important one for marine litter is the one that was held in March 2022, where 175 nations from the United Nations accepted and signed a resolution that aims to forge international legally binding instrument on plastic pollution. So we call it the Plastic Treaty. So since March 2022, experts for policy, international policy, and experts of the actual problem of marine litter have been meeting every 6 months to try to agree on this internationally binding treaty. On top of this, UNEP has put together what they call the GPML. So it is a global partnership on plastic pollution and marine litter. It supports the development of national marine litter and plastic pollution action plans. It was designed, it's a digital platform that is designed for and with developing countries and SID, the low-lying island countries, to make sure that they prepare for they prepare the actions to tackle the problem of marine litter that will then be enforced as by the treaty. So what they do is they engage with all stakeholders because they look at the problem from the very start. So when plastic is actually created all the way to when it ends up in the ocean, they work at defining a strategic approach, setting targets, designing the monitoring and review program. And why am I speaking of this particular problem is that we do not know so well what kind of marine litter there is actually in the ocean. I gave you some numbers before, but they are still very well. The brackets are still really wide, and it's still really important to know better and monitor marine litter. And why? Because we need to monitor to establish the current baseline of what is now in the ocean, and we need to assess the trends and results from the indicator. So this little loop here, this 8 loop, which is from UNEP Grid Arundel, shows you the importance of observing, of modeling marine litter, because we needed to set targets. We need this information to develop the policies. We need to make sure these policies are working. We need this observation to adjust and to implement the policies, and also to set indicators so we can actually monitor all of this. So this is this entire loop. And where do we fit in? GeoBlue Planet has co-created IMDOS, the Integrated Marine Debris Observing System, and we aim to support and strengthen the network of sustained observation to enhance marine debris research and inform action to tackle the growing problem. And this is where the digital twin becomes really handy, because you can use the digital twin once you have this information, this observation. You will then use the digital twin to inform the marine litter policy that are being designed right now. And this is how we're using EDITO, the European digital twin of the ocean. So EDITO, Chloe will go into the more technical details, but just to give you an idea here, it's a European platform that provides single point of entry to research, explore, and exploit, so 3 pillars, products and knowledge to support the digital twins of the ocean. So it integrates data of European platforms, Copernicus and ModNet. It provides an exhaustive reference to all these ocean data products. It provides some metadata-based search queries. It also enables people to add new data and then process all this data that is available. So this is the more schematic view of the European digital twin, with an explore phase where you can use the digital twin platform, the contribute phase where you can add data and you can use the services of the digital twin. But what is for my understanding, the most appropriate in the case of marine litter is really create, because we need to create these tools that will be useful to design the policies. So we need to assess the exposure, the connectivity, and so on. So the user input data that is going into the digital twin of the ocean and the models forcing the model as a source of plastic. We have riverine, we have coastal, we have different zones of interest. We also need to look at the age of plastic, and then we look at scenarios. So first of all, we need to assess the exposure. So basically you have on the top two figures, they show you the Indian Ocean. And first of all, it gives you on the left where the plastic goes after 1 year of running the Lagrangian model. So tracking all the little particles in the model, where the plastic goes from the river and where the plastic goes from directly the coastal area, the beach areas, and so on. So you can see already that the different type of sources of plastic will pollute different places in the ocean. Then we can also, and this will help you understand, where and how you will put your action. And then evaluate the connectivity. So this is just the two figures there. Maybe you can actually see my pointer. This is basically looking at the sources of the plastic that will end up on the shore of Sri Lanka. And you can see from this map that most of the plastic ending on the shore of Sri Lanka is actually not from Sri Lanka, it's from India. And then on the right part, you have the connectivity matrix that give you the time scale. So basically, if you look on very short time scale to the right, the marine debris on the shore of Sri Lanka comes from Sri Lanka. But if you look at longer time scale, most of the debris comes from India. And this gives you an idea of like, should I clean actually the beach of Sri Lanka to have the beach of Sri Lanka clean, or should I clean the beach of India to get the beaches of Sri Lanka clean? So that's what we call by connectivity. And then you can use what if scenario. So you build a scenario. What if I cut this river input, because a lot of plastic comes from river? What happens on this beach? Or what if I clean the entire economic zone of India? What happens to Sri Lanka? What if I clean the coast of whatever country? What happens? So that's what we call by what if scenario. And these all three help inform the policy design, assess the policy, and adjust the policy. And this is where, to me, the digital twin is a really important and a helpful tool that we can use. So just really rapidly how it works. So we start from the input from the continental and from the riverine waste, and then we run the model on the DTO platform. So all the little wiggles you see here is one particle of plastic that is represented in the model. And this is how we know what is going on the different beach of this Indian Ocean, the example that we have here. And then we can measure, quantify the exposure of plastics. And then you can identify a region where you want to prioritize action for mitigation and adaptation. So mitigation being the cleaning a river or cleaning a beach and so on. Adaptation is making sure that the plastic never reaches, the river. So that would be more the waste management part. And this tool can also support the compensation scheme, because this is where the treaty is going right now. It's like with the carbon trading. We're going there where, if we know India is actually the one littering the beach of Sri Lanka, maybe it should be India actually paying for the cleaning of Sri Lanka. But this is far beyond, my understanding and my knowledge, as I'm more of a technical expert. But this is what we are discussing right now with the INC, the Intergovernmental Negotiation Committee for this intergovernmental treaty. So now the question is for you guys. My application is marine litter, but what would be your application? The DTOs can be used for marine resource management. It can be used for fisheries, aquaculture management. It can be used for climate change impacts, marine coastal hazards, the flooding, the erosion. It can also be used for marine biodiversity conservation. So this question is for you. And someone will put in the chat, hopefully Julia or Lilian can do that, a link to the survey that has been created by and for early career ocean professional to bring your voice in the shaping the discussion that we will have in Barcelona, but more generally in the shaping of the digital twin of the oceans that are being created right now, so they can address your needs and not only the ones of the people right now working on the DTOs. So thank you very much, and I will give back the floor to Alfredo.
Thank you very much, Audrey, for this super interesting speech. How Audrey said, you can see the link now for the survey in our chat. But don't worry, after the event, we are going to share with you also again this link. So we have now the second of our speakers. So Toya, this is your moment. The floor is yours.
Thank you. I will share my screen. And present. Can you see everything?
Yes, we can.
Thank you. So yes, I will be presenting a little bit more, talking a little bit more about the EDITO platform. So what was done in the for this EDITO European Digital Twin of the Ocean. With first a little bit of the definition that Audrey already told you about, a platform overview, and the upcoming features that we hope to have very soon. So first of all, yes, what we hope to do is really to build a platform in order to provide tools for other people, you maybe, to create digital twins and to create what if application, what if scenario. So the idea is really to have this platform that is connected to data lake, both the Copernicus marine data and the EMONet ones, and some new data that the user will be able to add themselves, as well as some engine computation process in order to have computation close to the data, and thanks to these different tools to be able to build digital twins. The idea was to evolve from the portals, which had some problem, the marine data portal. And what we wanted to do was to facilitate the scientist works and reduce the cost. For that, as I was saying, we want to be able to effectively subset data, as well as create the processing function computation close to the data in order to avoid very heavy transfer of data information, and to be able to scale up and down the resources in order to only use what is useful. What is also was found as a problem was the contribution part that was really complex for the marine data portal. So here we are trying to help this contribution to make them more easy with tools as well as a way of working in an open and collaborative way on a highly available platform. So this was already presented very well. So yes, really the important point is that we want to provide this platform to build digital twins of the oceans, to all together create an interesting tool where each and everyone can participate, and to regroup all the information to have a single point of access to really make this more simple. What we found that the digital twin challenge was, what is a digital twin? We understood that is, as Audrey presented, the creation of what if scenario. In order for digital twin to exist, we need to have this scenario that allows user to have hypothesis. What if I do that? How does that impact the ocean, and what will be happening? And in order to take decision. So the what if scenario represents data that has never been generated before. And for that, we also need end user web services that will be available to any user. To create these web services, we will need the computation functions and the data. As we say, we try for them to be close together to avoid unnecessary data download, upload, and all of that. And that can also help to be able to create software asset materialization, which means that if we have a computation function that is able to create data, then we directly are able to reference the data, even if it's not yet available. We say, this data, we are able to create it, and if you ask for it, then it will be generated. As well, for all that, we need to have maybe new tools. So the idea is that we are already adding some of them, and maybe you will add the one you need to in the future. So here is a technological stack. I will not too much present this, but let's say that for each of these strats, the services, the processes, which are the computation function and the data, we have standard API to allow to search, monitor, and retrieve information, and for the service and processes also to execute, monitor, and stop the function of these services and processes. Now I will share with you the platform itself, which is here. So here is the platform that we have created. We have a service catalog. We are trying to have it a little bit more ocean-oriented, because at first it was very generic. So now it's beginning to have some nice tools like Jupyter Python, ocean science oriented. Sorry. This is a platform that you will be able to go to log into, to create an account. It's very easy. And this is to allow you to run these self-services, so you can launch a Jupyter notebook that you will be able to interact with. Then you can see the services that you are actually running. You have to be logged in to see your services, because you have to have an account to launch them. And so here I have a VS Code that is running, where I can directly interact with some data. You have some very nice tools like secrets to be able to have credentials protected. You have a data place, which for mine is empty for now, but which is an S3 bucket, which is your personal S3 bucket where you can upload files and then interact with them inside your self-services. And so that is what we are, what we call the data lab. But we also have, I think I have my, my sharing is doing some, sorry, I think it doesn't like that I have the presentation. Well, I'm blocked here, so let's stop the presentation here. It should help. Yes. So we have also some home presentation, some homepage, and some tutorials to help know how all this works. I don't know why Zoom is stopping me from interacting, but that is not nice. I will just present from here. That's not, I showed you the important part of the data lab. So we have here the homepage. We have some tutorials to help and interact with the platform. So you can go have a look at that. And we also have a viewer that allows to browse the data catalog. This is still a work in progress. So I will, sorry, come back to my presentation. And I will directly, yes, I can show you a bit of the data lake here. Up. So here we can you can have an overview of the actual browser of the data, but this should evolve pretty soon. We hope to have a viewer with a much nicer user experience with lots of new features available. And we hope to be able, we are already connected to some HPC, but the connection is still a little difficult, but we are improving it we are working on that. And what will be coming soon is that if you saw on the platform, we did not have the process catalog yet. So the computation functions were not really available in the interface, but that is we are also working on that to allow you to add computation processes and to launch them directly from the platform. And as Audrey presented with the what if scenario on plastic pollution, that is a little bit of how we see that kind of what if scenario and how it can be implemented inside of the platform with an interface that will allow to show data depending on what the parameter chosen were. If you call for river of 10% and coastal of 20% plastic presence, how that works. And to the blue are the processes that can be run based on the data in orange. And so the processes can be several processes that work together. And if you look at it on the software asset materialization, then you directly ask for plastic exposure with certain parameter, and then it will call the different computation function available to be able to compute this information. So I already showed you this different, so yes, here you can see the tutorials, that's good. And here you will have the different links to be able to access the platform. And the team, which are most of it's early career ocean professionals too, because we, as for myself, we are beginning in this domain, but it's so very interesting and so nice to participate in it. So thank you. That's all for me.
Thank you, Chloe. It is super interesting and not so technical that I wait. So finally is very useful. Well, we now have our last speaker. So presenting Iliad's project. So Babis, go ahead.
So hello everybody, nice to meet you also. Thanks, Alfredo. I'm going now to share my presentation. Please tell me if everything works fine. So can you see my presentation? Okay. So my name is Babis Ipektsidis. I'm coming from net company Intrasoft. I'm the member of the coordination team of the Iliad projects. And today I'm going to present you what's the digital twin of the ocean for Iliad. Iliad in a C-cell, the architecture that we use. We are not going to go into detail. We're going just to show a picture. And then about the Iliad Innovation Booster. So about Iliad. Iliad is a Horizon 2020 project. Coordinator is net company Intrasoft. The project started last year, February 2022. And it will end in 2025 next year. And we are in Iliad with 56 partners plus 2 linked third parties. So the project was funded under the Green Deal. So what are digital twins for Iliad? The very definition of its digital twin of the ocean for us in Iliad is to provide a virtual environment representing the ocean that is capable of running complex predictive management scenarios, and the innovative system that integrates across disciplines, sensors, models, region, and also digital infrastructures. So what we want is to make the Iliad digital twins of the ocean that are interoperable, data intensive, and of course they are, and cost effective. So about Iliad, we can divide Iliad in 3 pillars. We are creating interoperable digital twins of the ocean through connecting to existing data infrastructures, whether that's Copernicus, EMODnet, or others, but also enriching the available dataset by adding different observational technologies, local sensors, and also trying to integrate citizen science into our data structure. At the same time, we also create an open marketplace, the Iliad marketplace, where we provide space where a lot of these solutions, data, and algorithms, predictive capabilities could be hosted. The marketplace will be also a place where different models can be evaluated and compared. Finally, we are trying to, and we are providing solutions to solve some of the big challenges related to the ocean activity, and we do this by assembling a broad and diverse user community based on and around our marketplace, where also like-minded people in different organizations can come together and discuss the host of different solutions for blue development, sustainability, the economic growth around the marketplace. We also have the Iliad Academy, which is our educational platform. We also have the Blue Technology Business Innovation Facility, where a lot of startups or building ideas relating to blue growth could come and receive some sort of guidance in order to develop, and also following some certain standards. So Iliad is a multidisciplinary project combining several data spaces, multiple twins, standards, and best practices, which are key to develop solutions and durability. When we talk about ocean data, we talk about geophysical, chemical, biological, and also different other types of data and components. What the digital twin of the ocean tries to do is to create a visual environment representing an ocean and also capable of running complex and predictive models and scenarios. The digital twins that we develop could be specific to one sector or domain, but it could be also cross-discipline, getting data from multiple sensors, ranging numerous topics, and putting them all together as a partnership. We are very dynamic in that sense. We work with a number of different projects and also with initiatives that are both public and private. So Iliad has a thematic focus, and we are creating multiple twins. You can see also some of them here, the areas for them, and the twins are also local. So our twins range from renewable energy, offshore energy, to coastal activities, and harbors are also aquaculture. So there is a wide range of twins that are developing in Iliad. So for example, oil spills. We are doing this with many communities actors, and we're very open to engage with, so we are open to have you also part of our community. So as a short teaser, since we will not focus on it, you can see here the Iliad system of systems architecture. You can see the different data sources, data providers, our data service catalog, and also the front end. Here you can see the Iliad twins of feedback concept. And to be more precise, here we are structuring the project to 4 stages in digital twin pipeline: the digital twin representation, the digital twin analytics models, and visualization and interaction. So in the left, we have already a lot of sensors that provide the input from observations. Combining this with Earth observation, Copernicus, and other sources. Then we have a special activity on on citizen science with its own work package, as we are a project, and also interlinking with other projects on biodiversity and sociological data. And this goes into data lake of the digital twins for the engine. What we are now aiming to do is to ensure that we are interoperable with EDITO, so both EDITO Infra and the EDITO Model Lab, which again harmonizes with Destination Earth, with the data lake and the services. So what we're trying to do as ILET is to make sure that what we provide can be portable and interoperable with EDITO. We have the models and the link to AI modeling services, and then we have a lot of pilots and demonstrators. In fact, we have almost 20 of them, and those are in different areas, and the exposure of both the twins and the components will be done in the marketplace. The marketplace is not yet publicly available, but it will soon become. So at the same time, we have also the policy impact facility, where the objectives are to develop a set of policy engagement tools that can be used by the policy networks. We have the academy, and also other interested parties communicate on any policy implication. At the same time, we engage with key stakeholders to assess the current state, but also to make progress with regards to the goal of Destiny, Mission Starfish, European Green Deal, the UN Decade for Ocean Science, and the United Nations Sustainable Development Goals. We also facilitate policy harmonization between EU member states and non-EU countries. As in our consortium, we have also partners that are non-EU countries. For example, from Israel or from Morocco, or also from Tunisia. So, and I'm closing with this final slide from my side. We have also the Innovation Booster, which consists of the Academy, which makes use of these new technologies as they do not happen, technologies do not evolve every day. You need to have users that have some training, and we provide this, provide training, education support here. We have the ILET Blue Technology and Business Innovation Facility, where we are supporting the individual twins to actually find a business model and to find the necessary resources. And of course, this is related to the end users in the end. And when saying business, because business is a word that can have different connotations, it's not necessarily commercial, but can be also public in that sense, in the sense that also organizations have business models. So what we aim here is to find a sustainability plan for each of the individual digital twins that we are developing. And of course, as mentioned before, policy is also very important. And when you are developing these individual twins, you have to relate to different policies and regulations, but also using the technology, you can formulate and you can provide this knowledge and capacity to predict as means of influencing the policy and also making your contribution to the formation of new policies. The Digital Blue Growth Hub is meant to be a community of activities and supporting activities related to the blue economy. And finally, our marketplace will provide access to the digital twins of the ocean that we are developing. So the ones that we are developing, but also it will be open for other innovative suppliers. And having said that, this is my last slide. Thank you very much.
Perfect, thank you, Babis. So we have finished the 3 presentations. So now it's time to questions and discussing. I want to remember that this discussion is not recorded.